Hello friends, myself Darpan Suja. By profession, I am computer programmer. In this session, we will discuss about mesh grid, contour graph and contour lines. Let's start the discussion with question what is mesh grid? How to plot a three-dimensional surface on two-dimensional plot, that is contour graph and contour line. First of all, in step 1, we have two input vectors x and y. The value of x is 0, 3, 6 along x-axis and the value of y is 0 to 4 along y-axis. So we have two vector x and y having value 0, 3, 6 and 0 to 4. If we draw the plot in two-dimensional surface for this x and y value, it will look like something like this. Step 2. Now we want all the combination of data points from vector x of length 3 and vector y of length 3. This is our vector x having length 3, 0, 3, 6 and 0 to 4 y, and we want all the combination from x and y, that will give us 9 data points, and where x is our row and y is our column. To this we will call the function np.meshgrid, where np is numpy, which gives us the function meshgrid, which takes the two vectors as input x and y and returns us the two array h and v. H is a combination of 0, 3, 6, which will look like this 0, 3, 6, 0, 3, 6 and 0, 3, 6, and y is the combination of columns 0 to 4, 0 to 4, 0 to 4. Now we can make a rectangular grid from these two arrays with all the combination where like this x is equal to 0, y is equal to 0, 0, 0, now 0, 2, 0, 4, then 3, 0, 3, 2, 3, 4. You can see in this figure y 0, y 4, y 0, y 2, y 0, y x 0, y 0. Now x3, y 0, x3, y 2, x3, y 4. So from these two arrays, we have created a rectangular grid. In the step 1, we have two arrays x and y. We have two vector x and y, and we want to create the combination, all the combination of data points from vector x and vector y. For that, we have called the function mesh grid, which takes the two vectors x and y and give us the combination, all the combination in the forms of h and v, where h is represent the x vector in terms of rows and v represent the column in terms of vector y, and when you draw these h and y v on a rectangular grid, it would something look like this. So np.meshgrid transform the domain specified by the vector x and y into array h and v, which can be used to evaluate function of two variable and three-dimensional mesh surface plot. This line which can be used, we will see in the later in this section. First, see, transform the domain specified by vector x and y into array h and v, means to say it takes the parameter vector x and y and returns as the two arrays h and v, where h is rows of x and v is column, because we want to make all the combination of x and y. Now we can make the combination 0, 0, then 0, 2, then 0, 4, then 3, 0, 3, 2, 3, 4, then 6, 0, 6, 2, 6, 4, and we can draw it on the grid. Now from here it is clear that what is mesh grid. Mesh grid function takes two vectors and returns us the combination of all the data points. Transform the domain specified by the vector x and y into arrays h and v. So from the step 2, we get two arrays h and v. Now graph the data points from array h and v on two-dimensional surface. First line grid true, then I have a loop in a loop and draw all the text x0, h row, h column from 0, 0 position from the h and v vector and draw them onto the grid. In the step 4, now the second part of the definition. Second part says that which can be used to evaluate function of two variables. In the second part, we see pass the value of h row and column and v row and column to a function named blah blah. Any function named can be here and it returns a data row column. So we are passing hx and vy to a function named blah blah and the resultant output is data z. So we have two array h and v and we pass it to a function which outputs the array data. Suppose that it returns the array 1 to 1, 2, 5 to 1 to 1. It can be any number x square plus this function can return any x square plus y square or h square minus y square and output the data in the form of an array. So we have now h values, v values and data values. So all the combination of this means to say that from this position h0, v00, v00 and data 00 we have 001. Next is 302, next is 601. So next is 022, 325. We already have make a rectangular grid of all the combination of x and y. Now we have another thing, that is the resultant data. We have passed the h and y array, h and v array to a function named blah blah and have output data 1 to 1, 2, 5 to and 1 to 1. And we want to graph this data onto this rectangular grid. At x0, y0 position, this 0, position, our data is 1. This position 0, 1, 0, 1, 0, 1. That means 3, 2 position we have data. At 3, 2 position we have data 5. So how to graph it? Let's see. Now let's graph these value in two-dimensional surface. So I have draw these data with the xy values and you can see here x0, y2, z2, x0, y4, z1, x0, y0, z1 here at this position 0, 1, 2. So our column number 2, 0, 1, 2, row number 2. So 2, 2 position is 6, 4 and 1. So 2, 2 position is 6, 4 and 1. This is our 2, 2 position and x is where x is equal to 6, y is equal to 4 and our data point is equal to 1. So what I have done, I have taken the two vectors, I pass them to the np.meshGrid function which returns me all two arrays h and v, horizontal and vertical, means horizontal x values are horizontal rows and y values are vertical columns, so that I can make all the combination from this h and v. Then I have draw these h and v, I have graphed these h and v on a two-dimensional rectangular grid. Then I have passed this h and v to a function named blah blah or any function named, and that output me the an array that is data which have any kind of value, which can have any kind of value 1 to 1 to. For in this tutorial we have 1 to 1, 2, 5 to and 1 to 1. Then we have draw this x y, means to say this h v and data array, this h v and data array onto this rectangular grid. So what we have done, we have plot the three-dimensional data on to a two-dimensional format. We have x axis, y axis and z axis. On the x and y combination rectangular grid, we have taken our z value. Let's view this graph in three-dimensional format. In that three-dimensional format, we have h, v and data. We have plot. First we will draw a scatter diagram. Shift enter and it gives us the point in three-dimensional. These points are 0, 0, 1, means to say 0, 0 and 1, 6, 4 and 1, that is 6, 4 and 1. So if we draw a wireframe, then it will looks like this figure, this graph, and this is our wireframe. If we draw a contour graph, then it will look like this. Now see, we have three-dimensional surface: x value, y value and z value. X is h, y is, in our case, x is equal to h and y is equal to our v and z is our data. Let's move this graph into two-dimensional surface, that is in terms of x and y. X and y. So this is our x. Let's move it down. This is our x and this is our y. I have moved the graph, I have rotated the graph, three-dimensional graph into x and y terms in two-dimensional. Now it is looking like this. You can see different colors. These colors are showing our data value. For example, 6 is our x value and 0 is our y value and 1 is our data. Here 1 is our data and here 1 is our data. Here 1 is our data and it is showing this color. So this data is represented by in terms of these colors, and these colors are separated by these boundaries. You can see these boundaries, and these boundaries are called contour lines, and this graph is known as contour graph. Let's draw this contour graph onto a two-dimensional surface. This is looking like in our three-dimensional surface. So when you graph this thing into two-dimensional surface, this is our two-dimensional surface, all the combination of x and y, a rectangular grid, and our data points. So this point 1, 1, 1 we have graphed in this color, and when the value of z is equal to 5, we have this color. When the z is equal to 2, 2, 2, 2, here value is 2, 2, 2, so we have different color. So these colors are separated by contour lines. So contour line is a function of two variables, x and y, passed to a function, is a curve along which the function has a constant value, so that the curve joins points of equal values. Here value is 1, 1, 1. So these curves are with a constant value 1 have a single color, and here it has different color. It is a plane section of three-dimensional graph of the function x and y parallel to the xy plane. So xy is our plane, and this is our representation of three-dimensional surface in a two-dimensional format. So these are our contour lines. Let's draw these contour lines. So we have H array, V array and data array. I have drawn AX dot contour HV data. So this is our contour lines. Here the value is 1, 1, 1. So you can see this color. Here the value is equal to 5. So a contour line of a function of two variables h and v is a curve along which the function has a constant value. Here the value is constant 1, 1 and 1. Now we will draw a contour plot onto the two-dimensional surface. A contour plot is a graphical technique for representing a three-dimensional surface by plotting constant z slices. These are slices, these contour line, these slices, this is a slice, this is a slice, called contour on a two-dimensional surface. So we have h, v and data. Now this time I have called the function contour f, which draw a contour surface and a color bar which represent the value 1. Here 1, 1, 1. This color representing the 1 value in the contour graph. This function representing 5 value. Here at point at h is equal to 3 and y is equal to c. Let's check it. H 3 and y 2 and our value is 5. So contour graph plot can be created with AX contour function, it takes three arguments: a grid X value, a grid Y value, our grid X value and Y value, and a grid of Z values. The X and Y value represent the positions on the plot and Z value represented the contour levels. It is a level 1. This yellow type color is yellow. This is a level 5. Perhaps the most straightforward way to prepare such data is to use np.meshGrid function, which builds two-dimensional grids from one-dimensional array. So let's repeat the things. We have two one-dimensional vectors x and y. We have created a mesh grid, which is a rectangular grid with each combination of x and y vector. So np.meshGrid takes two one-dimensional vector and returns h and v horizontal vector and horizontal array and vertical array. That means x is our horizontal lines. We have three data points in x, so we have three rows, and y has 3 points, so we have 3 columns. After drawing the graph onto a two-dimensional surface, we have all the combination of h and v. So all the combination of this is our rectangular grid, this is our mesh grid. So mesh grid function specified by vectors x and y into arrays h and v. Then we have passed the h and v to any function which returns at the output array, the data array, and after that we have drawn these h and x and hv and our data onto two-dimensional format. After that, in the contour graph, this format is represented by the different levels with data slices that is known as contour lines. And when you see this into three-dimensional graph, it will look like this. When you convert it into two-dimension, it will look like something like x and y. So it's a tedious work to do this thing. Okay, let's again run it. So this is our xz. Okay, I run it again. Okay, this way, then this way. So this is our xy graph. Okay, I run it again and try again. So this is our xy graph. Now this is our xy graph. Here contour graph is representing different levels in terms of these colors and separated by these lines which are known as contour lines. So this is our rectangular mesh grid, have each combination of h and y, and on to these combination when passed to a function blah blah, and it returns us the data, that is z point, and it is represented in terms of graph like this into different levels. And contour line of a function of two variable is curved along which the function has constant values. There is constant value 1 1 1 and different value. These are known as contour lines. And a contour plot is a graphical technique for representing this three-dimensional surface onto two-dimensional format. This was our three-dimensional surface, and this is our three-dimensional surface, and we have represented it into two-dimensional surface in terms of contour graph and with the help of mesh grid. Let's take another example fastly. Suppose we have a function x and y, x square plus y square, two vector x and y. I have created a mesh grid from these two vectors x, and in terms of x and y, then I have my data points z. I have passed this x and y to function f. Let's see the definition. Our definition is transform the domain specified by vectors x and y into array h and v, means make the mesh grid, then pass it to the function these two variables and three-dimensional mesh surface plot. I have passed here these two arrays to the function f and create a data. After that I have draw this three-dimensional surface. So I have a contour graph onto a three-dimensional surface. If I want to create it onto two-dimensional surface, I have created the mesh grid. My function is equal to, my data is equal to x square plus y square minus 1, and onto the two dimension it will look like this. By these circles are contour line separating each level from the another. Let's see this three-dimensional graph into two dimension, how it looks like. Let's do this thing, and then x and y. This is our x and y. So this is our x and y, and you can see here in the middle we have this level that is 2.5 in the middle, and in the sides we have 17.5 level. So a contour graph, again I am repeating, a contour graph is a way to draw. So a contour plot is a graphical technique for representing three-dimensional surface by plotting constant z slices. These are our slices called contours on a two-dimensional format by using np.meshgrid, that is mesh grid from the np array. So I hope you understand the thing what I want to tell you for now. Bye. If okay, thanks.